Studies of Sathyabama Institute of Science and Technology. We welcome you for the second day FDP on Big Data Adaptation and Analytics of Cloud Platforms. Once again, we are very honored to welcome the eminent speaker of this FDP, Dr.Doreen, founder and director, Computational Intelligence Research Foundation, CIRF. We welcome you, Ma, and the session is yours. Thank you, Ma.
Thank you, Professor Anu, ma'am. So we are getting the participants on board. I know most of you are doing your work, and you have all joined. So before we start with the session, can I have some words? Okay, what?
Recording in progress.
Okay, the recording is getting started. All right. Can we have? What did we see yesterday? Some words on the chat. Yeah. Some words about big data. Thank you. Thank you. And what is big data? Yeah, that was the first talk we had, right? What is big data? It is not the size of data. If your application is not able to process it, then we say the data to be as big data. All right. And then, yes, we spoke about HDFS. We spoke about Mapreduce. Exactly. What about others? We have so many participants. Hadoop is a solution. And then what are the videos we saw? Just recollect, what are the videos we saw? The data to be as big data. All right. And then yes, we saw the video of Google's data center. Data center is where, yeah, we saw about Facebook's data center, where all your data are getting processed, all right. Then yes, data center, you remember how the servers, they don't have even ACs, all right, and then how do they process it? Using cooling towers, and they customize their own centers, okay, they customize their own servers. Then what are the other things we saw? Yes, yeah, the data center of Facebook is 4 football grounds. Nobody remembered about this. We were discussing about how many data for Facebook, the likes, the photos getting updated, YouTube permanent video, all right, petabytes of data, right? The watch time of YouTube. We saw about the Google searches, the Twitter, the LinkedIn. Yes, 4 football grounds, just 10 employees. Imagine in our college, the portion is the size is big, a number of people working inside every institution. We are also how intelligently they are working, right? All right. I'm so happy that you're listening and now you're able to respond. LinkedIn, yes, exactly, sorry. And then we eventually moved on into the Hadoop framework. You remember we moved on into this Hadoop framework. Remember this? I hope you're able to see big data centers. Yes, they are very big data centers. We cannot travel, but still we were able to see how generally they keep it over there. All right. Okay. Hope you're able to see in my screen, right? So today, and then we saw about two main components. We saw about HDFS, the introduction. Okay, then MapReduce. What is the main functionality of HDFS? What is the main functionality of HDFS? It is used to, I'm getting a message, store and manage, exactly, Lohit. Okay, Lohit sir, I don't know your sir, a student. All right, it stores and manages the data. Okay, and here we take Hadoop, it works students. Okay, Lohit, okay. So it works as a master and slave. Okay, so HDFS, it's mainly focusing on storing and managing the data. All right, it stores and manages the data. And what is the master component of HDFS? Everybody, you can give your answers on chat. What is the master component of HDFS? And what is the slave component of HDFS? Name node is the master component. What is the slave component of it? Data node. Exactly. I'm getting answers only from Rohit. Now I'm getting from Mehela. Okay, I don't know your staff or student. The name node it defines your master. To your slave, it is your data node. To your slave, it's your data node. All right, very well done. And then we move on. This one core component we have seen about HDFS. Today we are going to see about yarn and the functionalities, how you write programs using Mapreduce. Those are the things that we are going to see. We are going to see the commands of HDFS, the working of Mapreduce, and yarn. These are the three components that we are going to see in today. All right. And coming into Mapreduce component of HDFS, I want all the participants to answer. Otherwise, I think you are simply joining this. All right. And if you give me an answer, it looks even more better. Okay. Okay. What is the main functionality of Mapreduce? Computing and processing. Lohit, you're very fast, Lohit. Okay, it's used for computing and processing. It's used for computing and processing. Okay, so you have your storage unit is your HDFS, computation, and what is the master component of Mapreduce? What's the master component of Mapreduce? What's the master component of Mapreduce? Job tracker. Okay, job tracker, exactly right. Thank you, Mehela ma'am. I don't know Surya ma'am. Okay, and what is the slave component of Mapreduce? Task tracker, exactly right. So this is what you need to understand clearly before we move on to today's topic. So this is the entire structure. So today we are going to see about the HDFS commands. And we are going to see about yarn. Yarn, it stands for yet another resource negotiator. Yarn came into existence. I'll show you what is the version of Hadoop that I'm using. It started only from 2, after version 2 point, before which we didn't have yarn. All right. And today we are going to see the working of Mapreduce, yarn, and HDFS. Thank you, Mehela ma'am. You are a staff. All right. So, and this is what you all say. The master component of HDFS is name node. The slave component of HDFS is data node. And the master component of Mapreduce is job tracker. And the slave is task tracker. Okay. So, this is your master node. This is your slave nodes. Okay. So, I hope my entire screen is seen. Is my entire screen seen? One of you could give it onto the chat. Can you see my browser? So this is the URL of HDFS, localhost colon 970. If I am not starting it, if I'm not starting my Hadoop, the Hadoop distributed file system, you're able to see my entire screen? Can you see this site cannot be reached?
Yes, ma'am.
Okay, thank you. So I want to assure that entire screen is okay, which means I've not started my Hadoop, right? So in order to start in my Hadoop, yeah, thank you, Harshini. Okay, I go to my terminal. I'm opening a new terminal. Okay, this is my new terminal. I've already installed Hadoop. Hadoop installation, yeah, I've taken a lot of workshops to different colleges, making students, faculties to install, because installation is not that easy as we do it of other things. It needs some time and to type in the code, to download, extract it properly, and then do it. All right. So I'm not going into the installation of Hadoop now. So if I'm going to start Hadoop, start all.sh. Okay, I showed you before. See, can you see here Apache Hadoop daemons are getting started. So we have taken the binary format of it. Yesterday I showed you in the website. I have downloaded, and the latest version is 3.3.1. So this is how you start. Once your Hadoop nodes get started, once your Hadoop is started, you will be finding out using JPS command. You'll be finding what are the components it has been started, right? It takes time to start it. Okay. So can you see here name node? You know what is name node? It is the master. I've installed a single node Hadoop cluster for showing the demo for the session. All right. And then you see the slave component, the data node is getting started. I told you have resource manager, secondary name node. Suppose if the main name node fails, you go in for a secondary name node. It is getting started. All right. And eventually, let me see what is the next component getting started. You have your resource manager and the node managers. Okay, this comes under yarn. Okay. Now it is getting sorted. Okay. So, and then see what actually happens in Mapreduce, right? What actually happens in Mapreduce content is that you take your data, you split your data, map it, and then reduce it, and then you do your schedule. That is your Mapreduce schedule. Okay. You map, then you reduce it, and then you go on for scheduling. All right. Say for example, how many of you you have done your invigilations? Now, yeah, you can see the resource manager got started, the node manager, the yarn components are getting started. How many of you have done invigilation in your college? Or you have seen people invigilating it? Or as a student, you have taken up a test? Yes, no? Yes. Okay. See how does the process comes? Yeah, now I can show you if I put JPS. If I need to get all these components. Okay, I have my name node. You have to check data node, the node manager, resource manager, and my secondary name node. Now, if I go into my Chrome, see before it was there, right? Now, if I refresh it, you will be able to find out. See, the Hadoop has been started here. See, this is the Hadoop. This is the overview of Hadoop. This is the data node. Can you see in the overview? See, it's 612. I've started Hadoop at 612. All right. And the version is 3.3.1, the latest version I've installed. Okay. DFS, non-DFS, DFS remaining. How many live nodes? Only one live nodes. You can see the name node journal status, in which folder it has been progressed. A DF storage 233 GB. All right. And then you can see your data nodes. It's a single node Hadoop cluster, so it's showing a single. Can you see in which ID you can see your data node? In which ID you'll be able to see your data node? This is your data node. Can you see? Name node, localhost. This is the name node address. And also you can see another tab, localhost colon 8088. The cluster, okay, and this is your name node where it has been done. Can you see this is the directory user, local, LR, Hadoop, HDFS, temporary, DFS. Okay, moving on to your, this is the name node part of it. And this is where you have your Hadoop distributed file system. You go into utilities and then figure out, browse your file system, wherein you get your file system. Be very clear, this file system is different from what is already being stored in your, it is not your local data. It is this the data that is stored onto your HDFS. So if I give my root path here, I can see I've created what are the folders I've created. You'll be able to see it. Can you see the folders? I have a user, I've created another folder, local, seller, Hadoop, and input I have a file, f1.txt. Okay, I'm going to compute this. Okay, it's just a simple text file where we are going to see about a word count. Okay, counting of words. Okay, how it maps into it, and then how it is getting reduced. So this is my data. Hello world, how are you? Hello world. So it splits each word. I'm going to show you two methods, the inbuilt example of MapReduce, and also the how do you write a program and then how you do it. So both demos I'll be showing it to you today. So what it does, so you have a data, it goes and maps to hello comma 1, word comma 1, how comma 1, r comma 1, u comma 1, and then hello comma 1, world comma 1, key value pairs, how comma 1, r comma 1, u comma 1. And then what happens, it then converges. Okay, so it takes all hello into one. So hello comma 2, two words are there, so world comma 2, and how comma 2, and I can show you. Okay, it works in key value pass. It works in key value pass. The first step it maps, and the second step it reduces. Okay, it reduces. So for this example, this will be the one that I given to my MapReduce. All right. I hope you're able to see. Today the system is very slow because a lot of processes are getting running. So it works in key value pass. That is what you say. For example, I told you to understand the concept of MapReduce. Listen to this example very carefully. You know, everybody, you have done an invitation or you have taken up an exam. So every institution will have a controller of exam who prepares the timetable, who allocates invigilators, and the day before the exam, the invigilator or in advance, the faculties will be able to know what is the component that is mean for which room you're going to do, okay, where you're going to do. So this is a concept of MapReduce. Okay, so I'm going to take the file what I've taken. So I've got a file like hello world. Okay, how are you? Then the same thing I'm repeating it. Okay, so I want to find the number of word count. Okay, if I ask you, sorry, if I ask you, you will be able to tell very easily. Okay, hello, 1 minute. Okay, so this is my function I'm giving into it. So what is my objective? This is my problem statement. Word count is my problem statement. Okay, I have to count my words. Okay, this is my problem statement of MapReduce. So this is the component. So what am I going to do here? So first function is your mapper function. What happened? It is not typing. Mapper is one function that you need to write. Okay, and then the next thing that you need to write is your reducer function. Okay, reducer function. So this is how the MapReduce job scheduling algorithm works. So what happens here? I told you, do you remember one thing very important that you need to understand? MapReduce concept works in key value pairs. Key value pairs. Okay. So first step in mapping, you do your key value pairs, and then you do your reducing, and then you get your output. So this is your input. This is the system that goes. and then you will be getting your output. Are you all able to see my Jamboard? You're able to see? Yeah, thank you, Lohit. Okay. So what I'm going to do first, I'm going to do my key value test. So hello, comma 1. So what is my key? Hello is my key and my value is 1. What would be the next? World, comma 1. Then how, comma 1. Okay, this is how it's the mapper program looks like this. R, comma 1. Okay. And then you get u comma 1. Okay, u comma 1, and the same word I'm repeating it. So again it will be doing per word by word, and there are different kinds of shuffling and sorting. For this session, as most of you are new to it, I'm just taking the very simple method. So this is your key value paste. Okay, this is your key value paste, how it has been done. Okay, it's very okay, key value pass it is done. So then what happens in your reducer function? You could see you have a hello and you have a hello. Both get reduced to 1. Okay. Then you have hello, comma 2. Able to understand? Then when you take world as also 2, everything will be changed. Like in reducing, it reduces, because it's a very simple example I've taken. And if you have got multi-stage also, and this will be triggering to your output. This will be triggering to your output. So when you know this, this will be my output. So I'm getting my word count. Okay, this is how the Mapreduce concept works in. This is how the Mapreduce concept works in. Able to understand? You have an input, you have an output. The same thing, because it's only single stage and very simple example. You get this as your output. You will be getting this as your output. I'm giving my text file, I'll be getting my output. And for MapReduce, this word count, they're given in an inbuilt function and also an output function. So to understand this concept, see, I told you, you have a controller of examination who decides upon what is your exam schedule, and they will be informing he will be informing to the invigilators to the schedule. So what content invigilators will have? Once the COE decides the schedule, what content invigilator will have? What you will have? Can I get some answers? When you want to do an invigilation, what a faculty will have? Very well said, Surya ma'am. You have the date of the exam and which session, okay, that it contains your time, and is rightly said by the attendance or the attendance sheet you have, and you have the room number. Exactly, this is what I was expecting. You have given me the answers. So you all given to this. So he will have the entire set, but to the invigilator he will be having only what and the question paper on the day. Exactly said Meghla ma'am, the question paper. Okay, any more answers you can give? So this is a very simple example. Who's a master node here? Who's a master node here? To execute the examination, who will be a master node? Yeah, yes. The master node is your COE is your master node. Okay, your COE he contains all the data. Okay, he contains all the data. Okay, so it contains all your data. So what is the master node of HDF is? It is your, okay, he's a master node. And for this session to do, you have all your data. So what happens on the day of exam? This particular staff goes in to the hall with the invigilations, whatever he has given. Okay, he goes and he distributes it. So this invigilator who contains all the data, he is the name node. Okay, name node, because he knows everything and how to process what is to be done. All right, he goes to the room. Okay, now he goes to the exam hall. Exam hall. Who will be there in the exam hall? Students will be there. So invigilator is the master. No, is a master. Okay, you are the masters, and inside the exam hall, who will be there? Inside the exam hall, who will be there? Students will be there, right? So students, when you take students, students are the slaves. Okay, the slave. Don't think that slaves. The master node and the slave node. The invigilator is the master node. The student is. So if the HDFS component of master node, okay, if the HDFS component of, sorry, if the HDFS component of is the, because you know all the details. So the students will come, they know what is their exam. The schedule is also given to the student. The student will be writing their exams. So what will be the HDFS component of student? You're able to hear me? What is the HDFS component of student? If you are the invigilator and you are the master in the hall, okay, the students, they come, they are the slave node. What will be the HDFS component of the student? Yes, it's the data node. So, and then where do you store all these data? So the student know the exam, they have learned what they need to learn, and it depends on each student how they learn or come. Okay, where they learn and come. Okay. Okay, so this, where does this reside? Where does this reside? What does this reside? So when a student, when a faculty goes, she goes and distributes the paper to the students, and the students, they, you check the hall ticket and you distribute it to the students, and the students start writing their exams. So they know the subject, they know the questions, they know the answers, and they start writing. So HDFS component of the invigilator is their brain, and the HDFS component of student, their brain, they know what content they'll be able to write it. So this COE contains all the input files. He maps it to different invigilators. So this invigilator maps it to different students. Each student, their question paper, after checking the hall ticket, you distribute the answer sheets to the students. Once students complete the test, what do? You, after the students writes the test, you collect the paper. Yes, you collect the paper. Then what do? Then you submit it. Here you distribute. If there are two or three students onto the same, you distribute it. You map the question paper according to the student year and what exam the student is going to write. So here and there, your simple example of your mapping works. Your map your concept. When student comes, you check, they distribute the question paper after checking the hall ticket, or second there's a different question, third a different question, according to the key value plus the question, the student year, and which subject they are going to write. And the students write the exam. So the entire concept is you are doing a mapping concept to the students. So your mapper.py or the mapper.java algorithm runs here. After the student writes the exam, what happens here? You collect the paper. Okay, you collect the paper. Then what do? After you collect the paper, then you arrange it according to, reduce it according to different years. It's not okay. 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 Then you arrange it according to second year or third year or whatever it is, first years or second years. Then you are reducing it. Here you are distributing it. There you do your mapper algorithm, and there you are arranging it, and then you go to your COE and submit your papers. And this COE collects all the papers, and then he reduces according to each row. Can you understand the concept of mapper and reducer? I'm just giving an example of this. So the same way, your mapper and reducer, and you get your output. Okay, this is the simple example of distribution of question papers from the COE to the faculties, from the faculties to the students. You map them, and then you reduce it, and the major reduction does at the master node, that is your COE. Okay, so here the component is your job tracker. The students, the task tracker, they have to write their exams within 3 hours or 2.5 hours or whatever is defined. So the job tracker of the faculty is having the job tracker. You are the master and you keep walking, checking them, telling them. So you have 1 more hour more, 10 minutes left or 5 minutes less. But what is the task of the student? The task tracker is the student component. They'll be writing the exams. Whatever they've learned, they'll be able to take up the exams. Now, are you able to understand the concept of Mapreduce? Yes, no? Yes? You're all connected? Yes, thank you. So this is a simple example of Mapreduce. Okay, this is an example of how the mapper and reducer works. So to start off with, I'll come to this HDFS function a little later. Yesterday I showed you how this inbuilt algorithm runs. Okay, today I'm going to, see, this is the functions for HDFS. So I told you when you have a different function, if you want to create a directory, Hadoop fs -mkdir, and I have to give the path. Okay. Say for example, you can see here, I have, this is my, sorry. Okay, this is my Hadoop distributed file system. I have user and user. Now I'll show you, I'll create a demo, right? Hadoop. This is not a local file. This is what I'm going to create a demo. Okay, Hadoop fs -makedir demo. Okay, so this is one function to create a folder onto a Hadoop file system. So here you can see it has been created. Once the function runs here, we can go and refresh it and see over there. Okay, so this particular folder does not reside on your local system, rather it is onto your Hadoop distributed file system, which is totally not onto your local system. All right, so now the function is run, it's completed. Let me check it. Can you see here? I've created a folder called demo. Okay, so this is the function. This is the Hadoop HDFS function, Hadoop FS makedir, which path I want to do. If I want to find out the list of files, okay, then I have to give as, okay, Hadoop. Okay, you can see this is the function Hadoop fs -ls Hadoop file system -ls/. So I'm giving my home directory, and from the path, whatever the files are being stored in my Hadoop system will be shown here. Because it is not your local system, whatever files are available in my Hadoop distributed file system will be shown here. All right. So everything, this is different, it is local, and that is on your HDFS. Okay, can you see? I had 3 folders and it is showing me all the 3 folders. You have Hadoop, user, Hadoop, demo. Okay, so this is their next function. So if I want to put a local file into my destination, okay, HDFS, put, then I have to give the path. Okay, I don't know, do I have anything? I have a lot of files. There is some CSV, baseball.csv. Can you see here? Baseball.csv. I'm trying to load it into the folder demo. So the function is Hadoop fs -put. Okay. So here you can see Hadoop system -put. I have to give my local system, local file, that is the baseball.csv. That is what, into my new folder that I've created. Demo, I've created a folder, right? I'm going to put from my local system to my data onto my HDFS. Once it is run, you'll be able to see it. Okay. See here, when I click on demo, I don't know whether it is completed, still running. Once it is done, you'll be able to see to it. Okay. Yeah, it is done. Now I can see whether, let's check whether days ball CSV. See, it has got loaded. This is a different file system. This is an HDFS file system. You can head the file. So the first few rows, see, it's an ID of a base player. It's a CSV file. Maybe I should have used it for some data analytics work. That at CIRF we train students and faculties, and now internship is going on for students and also faculties, both online and offline. Hands-on sessions are being taken and research scholars are with us, and we have one-to-one sessions, finding problem definition, helping, and you develop projects on your own. It's not that we develop and give. I just knew, and there are many successful candidates who have completed and people are doing on their own. Okay, I'm just guiding them in developing how to develop and train them onto the technologies. Same thing I can get from my HDFS to my local system. So from which place what data I have, I can also get it. Okay, and also I can use HDFS-cat. Okay, Hadoop. Can you see here? Hadoop FS-cat. So cat, it is used to what do I say? It is used to read or just print the data. So I have this file called user local. Okay, then seller. I have in this path Hadoop input, and I've got one thing called f1.txt. I will show to you. See, not this. I'm going to go into this path. You can see user local seller Hadoop input. I have a file called f1.txt. If you want to read or to see it, I can just read it using this command, where it goes fetches my file from HDFS and you'll be able to view it from here. Okay. Are you able to understand? So it's a very simple file. So there are different other, you can copy from your source to destination, you can move, okay, you can remove the files, okay, you can merge because you work with big volume of data and you get it into parts and you can merge it. Okay? So it's can you see here that file what I have loaded? You're able to see here. Are you able to see? Hello world, how are you? Hello world. This is the file. Able to understand till now? We have seen the concept of Mapreduce and then different commands using HDFS. Okay, so I told you I have already used this function and I've made a directory and I've uploaded f1.txt HDFS dfs-put this text onto my, from using put, I use my local system. I've shown you a demo of it also. Is it clear till now whatever we've seen? Are you able to understand little about it? Yes or no? Are you all there? Hello? Is my audio? You are able to hear me?
Yes, ma'am.
Okay, okay. Is it clear whatever we have seen till now? Able to understand at least a bit of the concept of mapper and reducer? I'm not getting any answers from the participants on the chat. Yes, ma'am. Okay. Jayanti ma'am, Lakshmi ma'am, Megla ma'am, Damodaran sir. Yes, what is the difference between HDFS? Your file runs on the Hadoop distributed file system, which is nowhere connected to your local system. Once when you start Hadoop, when you start working even with more volume of data, it is all splitted into your different data nodes and it can work. Okay, it is not using the storage of your local system. Yes, Mohit? Okay. Okay, most of you said that you're able to understand. Now, inside this user local seller Hadoop, this is a version, they have given an inbuilt Mapreduce example of word count program. Okay, I'm going to run the program. Okay, already I will check, but I have to create a new thing onto my output. I will check what are the files I've done till F1, F2, F3, F4. Let me give F7. Okay, so F7. So I'm using inbuilt Mapreduce example jar that is available. Hadoop jar, user local seller Hadoop. Okay, and share Hadoop. This is under this path. I will show you that path. All right, share Hadoop Mapreduce examples. All right, and this is the jar word, the word count. Okay, I have not coded. It is what is inside my Hadoop distribution. And once I give this, Java archive file, right? So that is already been done. And next demo, I will show you how you can write your own word count problem, and then you'll be able to do it. All right. So it computes. You remember I showed you how the mapper and reducer works on this Jamboard? Do you remember this MapReduce? Okay, it maps and then reduces. And the problem statement that I've taken is a very, very simple word count. And I have got one more data set, which is of Uber, right? You use Ola and Uber trips. So which day, which vehicle has got more active trips, or where the gain was more? Okay, the same using MapReduce component. I will show you how the code works, but in depth of code description, we don't have much time. Okay, it has completed. Can you see this is how the job? How many mappers? See, I've given this function here. Okay. See, I gave my functions here. Hadoop F7, it goes to your Hadoop file and then it works. Can you see the job scheduling, the scheduled matrix, submit of tokens, waiting for map task. Okay, then it 0% mapper and reducer, and then it goes into it goes and reads the file F1, and then how many map input records, output records. Okay, combine maps, splits, combines input and output. I showed it how it maps and reduces. Okay, and then once everything is done, mapper is 100% completed, reducer is so it is mapping it. Once that is done, eventually when you come down, once it is completing the task, the mapper will be 0 and the reducer will be 100%. And then so many works are being done onto your Hadoop. Can you see merge marker, the 3 sorted merge segments? All right, here you can see how many rows. See, mapper is 100% completed, the job scheduled, and reducer is 100% completed. And this is how it works. Now, let's go into the HDFS. So I gave F7, I suppose. Now, see, it is F6, now only F7. Can you see? 1843, it has started. So once I click it on, I can see the output here. So you work 100 blocks of data, you get in different parts. That is where in HDFS you will be using get merge to combine it. See, when I'm going to see this file, what is the option that it has taken? Okay. So how many mappers, how many reduces. Okay. So this is how you get output. Hello to, how to, R2, world to, and U2. Can you see here? Can you see? This is how your word count problem. You can also download it and keep it. Okay, you can also download it and keep it. Oh, I've given the entire F1. That is what I should not give the entire input. I should, so all the files it has taken, I have to give f1.txt, and if I give f8, you will be able to do it. That's what it has taken, all the files, whatever is in the input, right? That is what I'm getting output. See, when I want, why, how I'm getting the, see, whatever is in the input folder, all the folder, I've got that Uber data, F1 text, Tube data. So all those have been taken into it, and then I'm getting it here. Okay. That is how, that is why when I show here, for F7, it was showing like that, part 1. See, one is a HTML kind of text that I had. Uber, then see the features, integration feature. Whatever words are available, it does the mapper and yeah, reduces. Okay, so it's more content. It's difficult for you to see. I think I've given the F1. Let's see. Okay, and moving on to the user-defined method. Okay, there are different algorithms, there are different examples available. See, and you can work it on how to aggregate word counts. Yesterday I showed you about pi, and it works in key value pairs. It works in key value pairs. So Mapreduce is a programming model to work with data within HDFS. Only the values within HDFS should be able to do. The programming language is Java, and also you can use Python, Spark also. Okay, you can use Python, as we don't have time. If you're interested, you can join learning about this. So entire hands-on set will be given. Okay, as faculties, when you learn and when you equip yourself through you, thousands and thousands of students can learn these technologies. And I showed you onto the Jamboard how it works. It works with key value pairs. You remember hello, comma one, world, comma one. Okay, so here, that's what. This is how the input mapper, the reducer I already shown you. These are the packages that you need to input. Okay, import java.io.exception, the utils, the fs path, the io, the Mapreduce. So a Mapreduce program especially consists of 3 parts. One is the driver, the second is the mapper, and third is the reducer. I'm not going to dive into the programming statement as we have got very less time. Okay, I will be showing you the entire structure of it, how it works. Okay, the driver, mapper, and reducer. So the driver is the first. So the driver program runs on the client machine. Here, for example, I'm going to use my client, and my server will be the same machines. Okay, it will be the same machine because it's a single node Hadoop cluster. Where to contain your main method of your Java program is here. For this example, is there your driver code. So I imported my Hadoop file system. I'm going to take my file system that is allocated onto my Hadoop. Output should not be present before running. That's what every time I give a, first time I gave F8, F7, but now I have given F8. Let me check whether I've got the output. See, I've got the output over here. So there. Yeah. So can you see now in F8, I exactly gave only f1.txt, so I'm getting only those files, the word count files. Okay. So now the same example I'm going to show you. So in most of the cases, the driver, the path, you have to give your input path, where is your output path, and the output part should not be there. Okay. As we don't have much time, I'm not going into it, into the steps. Okay. And then this will be your sample program. You need to create the job object. What is the key management, the key types, the reducers, all right. And then you have the mapper function and your reducer function. So here I'm splitting it. So hello Hadoop, goodbye Hadoop is my word. So it is using tokenizer, the word, and one, the key value pairs. And what do I do in my reducer? I'm not going into the steps of it, as we don't have much time. And I'm going to sum it off my values, not the key. I'll have the key, I have the values. So these are the common libraries for the reducers function. Okay, the reducer function. All right. So then you have 3 parts. One is a driver, your reducer, and your mapper function. So I have done it using NetBeans. Okay. And the next example, I've taken a Uber data. Okay, Uber data. I can show you before NetBeans gets loaded into it. So, and in that, I will be showing you a demo of how it works. See, this is the Uber data. So how many onto the date, onto the batch, onto the particular, how many active vehicles, so many number of trips. Okay, vehicles and the number of trips. Okay, using which the function of, I'll be splitting into the days. I'm going to find out using the same data. I'm going to use the find the days on which the basement has more number of trips. The first date B00 and the basement has more number of trips. Second program, I'm going to show finding the days on which the basement has more number of active trips. First is number of trips. The second function that I'm going to do is no more number of active vehicles onto the basement. First is the number of trips and next is more on basement. I don't know whether it beans open. What happened? It means, is it opening or not? Yeah, now only it's getting open. So here I've written the coding for the normal word count. There are different programs I work and research scholars have also done working on this, on different medical applications, because they work with large volume of data. Right? Okay. So these are the two things that I'll be showing it to you until it is getting loaded. Okay. By the time that it is getting loaded, I will show you about, explain you about YARN. YARN, it stands for yet another resource negotiator. It's a resource manager. You have seen like node manager and your resource manager, right? YARN was introduced after Hadoop 2.0, right? Before for Hadoop 1.0 version, we didn't have YARN. Okay, what it does, it splits. Okay, it splits the functionality of resource management, okay, and job scheduling and monitors into separate devices. Okay, it does the resource management and job scheduling. So different resources data node that could run. All right, the idea is to have a global resource manager, and per application we have an application manager. So you have a resource manager and a application manager. So an application is either a single job or a DAG. Okay, directed is cyclic. So you have two components on your YARN. That is your node manager and your resource manager. When I ran JPS, okay, when I ran JPS, you were able to see a resource manager and a node manager, like name node, secondary name node, data node, and then you had your resource manager and node manager. Those are the Mapreduce these are the YARN components. So this is the ultimate authority where number of resources among all the applications. The node manager is the per machine framework for particular machine. How it monitors the resource. Overall is a resource manager. Then you have got per application and application manager. All right. So this is how it works. So this is how it works. You have different clients, you have a major resource manager, and you've got different node manager and application manager. So can you see at the MapReduce status? So from the manager, it goes to the application, and then you get your this is how your yarn works, the resource manager and the node manager. And when you take into the resource manager, you have two components in resource manager, the scheduler and your application manager. Scheduler, it allocates to which data node that it needs to allocate. It's a pure job scheduling work. Even when we ran on word count, it has done it. All right. And then different schedulers are, the capacity schedulers are available, or fair schedulers. These are some examples of plug-in schedulers. And if you are a researcher, you can start writing your own scheduling algorithm. You've got a broad area to work on with that. So when you take resource manager, the scheduler, the application manager, when you take application manager, it accepts the job. So a resource manager has two things. One is a scheduler and an application manager. Okay. So yarn, you can see yarn version, yarn node help, yarn list, yarn status. All right. And yarn states. All right. So close it. So this is the word count problem. Now I'll show you the word count program first. See, this is my word count program that I've written in my source. Can you see the NetBeans? Can you see the NetBeans page? Application participants, or all you are in a hurry in filling up your feedbacks or quitting it? Are you able to see the NetBeans page? Hello there. Yes, 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 yes. Thank you. Thank you. Okay. So here you see the word count, and this is my Java program. I told, right, you have a driver program, you have a mapper program. These are set of header files. Can you see you have your main function of your map program, the mapper, and then you come into your reducer program. Then you come into main, this is your driver program. Okay, so I've given what are the needed things, and then I will be doing uh, the clean and build function of it. Okay, once it is done, okay, the same thing I'm going to take cd user Doreen Robin NetBeans project word count. Okay, ls. So inside my word count, why it is taking such a lot of time. So these are files I'm going. See, you can see here when I clean, it is building it, clean and build. So it's cleaning, and you will be able to see your jar files here once it is done. Let it go. See, it's very huge. It's very huge. In order to understand, you need to learn a lot, learn more. I think as we're running short of time, I will not be able to show you Uber. Yeah, see, into your dist file, into your dist folder, a jar file will be created. We need to wait upon it before. First time what I showed you is a example jar that Hadoop itself is creating. This is how you use it. See, your researchers or your lab programs, you can write your own scheduling algorithms and then give it to students to work on with. Yeah, it is building the jar. Can you see onto user Doreen NetBeans word count, this type got the jar file. So now what I'm going to go, I'm going to go into this. I can see here. So Hadoop jar. So jar, I have this word count dot jar. I have to give my user path, user local, where I have my input on h2 input slash f1 dot text. So already till what number we have got, I need to figure it out before I give it. If I give it my output, because I have to every time I need to give it f8, so I give f9. Okay, I'm going to have my output user local or Hadoop output f9. F9. So this is what I have done user defined. Okay, first what I ran is an inbuilt function. What I ran is an inbuilt function. So once this runs, we'll be getting an output f9, and this is how I've written the program for Uber. I told you, right, the data set. This is the program uber1.java. Okay, how we have a batch number for each batch, what is active trips. So same way you have three things. Here I'm splitting into dates. I have a date on the data set, you can see, and with the basements I'm going to split it off, and then I'm going to merge it using the reducer. And okay, I'm until that gets ready, I'm trying to make this ready. Yeah, it is running. So you're able to understand little concepts about Hadoop, Mapreduce, the HDFS commands, and yarn commands. Some of it we have seen today.
Yes, ma'am.
Okay, thank you. But you need a lot of time to explore if you want to learn. Once you learn very well, through you have a good hands-on experience through which many students through you will be getting benefited. Okay, it's done here. Then let me go and check whether I've got F9. I got F9, the same file only I've given. So I will be getting the same. That was an inbuilt function. What I run now is a user-defined function, what we have done. All right. The same thing here, it works with Uber also. Okay. And so Uber 1, ls, change directing to this. I have my jar files here. Same thing here, Hadoop jar. Uber1.jar. I have my file on user, local, cellar, Hadoop, input. I have got Uber data. I've got my Uber data here. Input, I've got Uber data.csv. Data.csv. That's my input. I have to give my output. F9 I gave last. I will be giving F10. Okay, I will give F10. So what happened? F10 onto this new file. It will run, and from this will be this is your data set. When I click on Uber data, you can see it off how it works. See the batch number, the date, the number of active trips, and total trips. Okay, I'm going to see first example. I told what we will be showing you only the first query I'll run, not the second one, as we don't find the day on which the basement has more number of trips. Only that I'm running it. It will take time, little 1 minute or so. So today, before that, I will recap. We have started with the entire HDFS, most of the functions, commands, how it works, how your local system is different from HDFS. How do you start? I showed you a demo. How do you start the Hadoop, the name node, and the data node? And then how do you put your files onto your system, and then how do you return back to your system? How do you create a directory? And then we saw an example of Mapreduce. Remember the controller of examination example. Then I showed you using Jamcode how it works in Mapper and reduce the concepts, the key value pairs. And then we started working to run in Mapreduce function. Then how it works, and then we moved on into the user-defined functions, and then how it works, what are the commands used for it. Let's see if I gave, so it went to the next page. Here is F10. So that is the first I show. Can you see on B, this date, it has the highest number of trips, and it is sorted accordingly for every basements on Uber. Okay, I've got a lot of data onto it, so you can you can see to it. Okay, so thank you all. Over to the organizers.
Thank you, ma'am. Thank you for your valuable information. I hope second day FTP has went successfully with your valuable information, and all the participants, I hope they have got the eye open for the Hadoop. Surely they will work, and if they have any issues or any problem, they will be contacting you, ma'am. Thank you for your support. Thank you, ma'am. We will meet in the third day of the FTP.
Thank you.
Ma'am, we have to take a snapshot.
Yes, just 1 minute, ma'am. Dear participant, please turn on video for the photo session. Dear participants, please turn on your video for the photo session. Yes, ma'am. Anu, ma'am.
No one has turned on. Okay, ma'am. Dear participants, kindly start your video for only 1 minute, okay?
For only 1 minute, just
Yeah,
to
yeah.
show your face.
Yes. Asking permission? Okay, 1 minute. Okay.
ஆமா.
Anu, ma'am, it's okay.
One more minute, ma'am. Now only everyone is switching on the video. Only 1 minute.
Hello,
Let's
Surya
wait for
ma'am.
one.
Hello, Beulah ma'am. I know some of them.
Okay. Okay, ma'am. Thank you.
And thank you, Doreen, ma'am. And thank you, participants. We will meet up on the third day of the workshop tomorrow. Thank you. Thank you all.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. Okay.